Hello, and welcome to a little video about simplifying rational expressions. There's the title. Okay, so the first thing that we're going to do with each of these expressions is factor the tops and bottoms. Now, the top of this first one, it's a monomial. I can't factor it any further. On the bottom, in that binomial, I can actually factor out a greatest common factor of 5x squared because I can divide 5 and 20 by 5, and x squared is the smallest exponent I see. Okay, let's check this out. Now on top I have a monomial, and on the bottom I have a monomial and a binomial. So I can only cross off things that are similar types. So I have a 5x to the third and a 5x squared, both monomials. Let's reduce. Now the first thing that I'm going to reduce are the 5's. They just cancel out, right? 5 over 5. Let me write that down. It's 1. They just cancel out. Okay. Now I see that I have 2 x's on the bottom and 3 on top. Let's use our knowledge of exponents. That means we reduce. If we reduce the 2 here, there's 1 left on top. And that's it. I'm left with x over x minus 4. I cannot cancel out those x's because if I cancel out the x on the bottom, then that's not the whole polynomial. That's just part of it. So I can't do that. It's all or nothing for polynomials like that. Monomials with monomials, binomials with binomials. We have a mono and a binomial, so that's really as far as we can take it. Let's try another. Okay. Let's factor the top. I see a GCF there, 2x squared. I'm left with x minus 2. And on the bottom, I can't really factor anything out of that 2x. Let's reduce. I can reduce the 2's. Boop, boop. And if I cancel out 1x from the bottom, I must cancel 1 from the top. So I'm just left with an x to the first. So just a regular x. Now since I canceled everything from the bottom, I technically have a 1 there. So theoretically, our answer is x times x over 2 over 1. But we really do not need that over 1. So here's our answer. Let's try that again. On the top, I see a greatest common factor of 21x. And on the bottom, I see a greatest common factor of 7. All right. I noticed that the binomials are different, so I can't really do anything to the things in parentheses. However, reminder that we have 21 over 7, which is 3 over 1. So that becomes a 3. That becomes a, that's an ugly one. Let's try that one again. There we go. Now the x just kind of hangs out. That's okay that it didn't reduce, even though it's part of the monomial. We are left with x times x minus 5 all over x minus 8. Now, if you wanted to write the 1 in front of the parentheses, you can do that. We just don't need to, so I'm not going to. Okay, not bad for these first 3. Let's get into factoring a little deeper here with these next few. Boom, 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 boom. Okay, so let's factor the top. Now, I'm not going to go over the process of factoring. If you have questions about that, let me know. We can go over that if you're my student. Otherwise, you are welcome to check out some of the other factoring videos or ask your teacher. All right, let's check this out. This factors into x minus 7, x plus 6. And the bottom factors into x minus 7, x plus 7. Let's see what we can reduce. On top, I see an x minus 7, and on the bottom, I see an x minus 7. I can cross those off completely. All I'm left with here is x plus 6 and x plus 7. As tempting as it is to cross those x's off, we cannot. They are both attached to something else. The top's attached to plus 6, the bottom to the plus 7. Okay, let's check this one out. All right, let's factor the top. The top we can factor out a 2. And on the bottom, this is what we have as factoring. Beautiful. All right, so awesome sauce. We can actually cross something off. We can cross off the x plus 3's. And yeah, that's it. We can't do that. We can't take that any further. 2 over x minus 7. All right, not bad. Let's zoom out to see this beauty. Look at all these canceling and simplifyingness. Now let's check out this kind of crazy one. Let's zoom in. Come on, computer. There we go. Okie dokie. Now we've got to fully factor this. The first thing that I notice is that I can actually factor out a greatest common factor on top. And now that I've done that, let's move this to the bottom. I can factor that even further. Unfortunately for us, the bottom part of our fraction, there is no GCF. So we're going to actually have to use our AC method. I'm going to kind of hint at it so that it's a little easier for you to understand. ABC. AC is negative 20, not negative 24. It's negative 72. B is 14. So that's 18 and negative 4. 18 times negative 4 is negative 72. 18 plus negative 4 is 14. I take those two numbers, I plop them in here. And then you would continue to factor by grouping. On this side, we can take out a 3x. And on this side, we have a greatest common factor of 4. So this factors into 3x minus 4 and x plus 6. Again, if you'd like more detail on factoring problems such as those, refer to my factoring video. Or if you're a student of mine, ask me. Alrighty, last step. Let's cancel out anything that we can. I see just an x plus 6 that I can reduce. So we have a 3 and an x plus 2 over 3x minus 4. Whoops, I forgot to close that. Can I cancel those 3's out? So tempting, but no, we can't. This 3 is attached to an x, which is attached to a minus 4. And this one is just in front of these parentheses. So they are not the same, not at all, not one bit. No way, Jose. This is as far as we can take it. Okay. I hope this was helpful. If you have any questions, please feel free to ask me or your teachers or Google, whatever you'd like. One way or another, have a wonderful rest of your day, whatever day it is for you. Bye.